Hello, voice check. Hello. Good morning, everyone. Welcome to Gate Wallah. How are you all? How is your gate preparation going on? This is Satish Kumar Drishetti, Faculty of Computer Organization and Architecture. Today, we are going to take a session on revision through the questions. Revision through the questions on the computer organization architecture. I have collected super 10 questions, and through these questions, all the concepts of computer organization architecture, we are going to brush it up. Already, we have taken some one-shot series on computer organization architecture. So, I have taken almost 5 classes, live classes I have taken. In the live classes, we have the content of computer organization architecture. This particular subject COA is only for the ECE people, not for the EE or not for the instrumentation. Of course, CSE people are having, but the syllabus of CSE is vast comparatively ECE. So, this syllabus COA comes under, actually COA comes under what? COA comes under digital electronics. Along with the digital electronics, we are having some 4 topics, just the basics of computer organization architecture and what address ALU path, data path, control unit, addressing modes, next pipelining. So these are the 4 topics. Major topics are addressing modes and CPU, data path, and next pipelining. So these 3 topics are most important. So now let us start the questions. How many of you are ready for the session? So jitne log, whoever the session watching, ek bar please try to keep hash ready. So yes, so that we can start the session. Yes, Soumit Chaudhary will start the session. Now here comes the first question. This question is MCQ question, multiple choice question. A digital computer has an instruction set. So topic is mission instructions. So topic we can take from mission instructions. So how to solve this question? A digital computer has an instruction set supporting 250 different operations. The instruction have a opcode and 2 address fields of 6 bits each. Then the size of each instruction is it. How to solve this type of problem? Every time, if you see the COA questions of the CSE paper, of course we don't have much collection of ECE questions. ECE paper we didn't have one question up to now in the GATE examination. We don't have the history of COA for the ECE people, but from the CSE people paper, so we have many times this type of model questions were asked. So how to solve this question? If you see, a digital computer has an instruction set supporting 250 different operations. So first of all, it is having what? The instruction have a opcode and 2 address fields. So it is having opcode and 2 address fields, my dear. So if you see the instruction format, what it is having? It is having a opcode and it is having address field 1 and it is having address field 2. So this I can take it as opcode. So this is address field 1 and this is address field 2, my dear. Okay. So what is given? A digital computer has an instruction set supporting 250 different operations. So here what is given? The number of operations given as 250. So number of operations means the number of types of operation, 250 different operations. 250 different operations means it includes number of opcodes. So it includes what? Number of opcodes. The number of operations or opcodes that can be supported is 250. Then what is the size of the opcode? So always, if the size of the opcode is n, then the number of opcodes will be 2 power n. That everybody knows. Okay. If the size of the opcode is n, the number of opcodes will be 2 power n. So what to do now? So what is the size of the opcode? So if you take 2 power 8, it is coming as 256. Am I right or not? So we need the n. Suppose if I am taking 2 power 7, it is coming 128. So 128 cannot separate these 250 operations, right? So that's why I am taking n is equal to 8. So 2 power 8 I am getting 256. Out of 256, 250 operations are supported. So the n will be 8. The size of the opcode is how much? 8 bits. So if I have a 8-bit opcode, that means 0000000, this is one operation. 0000001, one operation, like that. Okay, very good. So n is equal to 8-bit, my dear. So this is 8-bit. Opcode size is given as 8-bit, and two address fields. Each address field is having 6 bits. So this is 6 bits. So this is 6 bits. So total together, how much it is going to be? So total together 20 bits. Yes or not? So what is the size of the instruction? That is a question. Then the size of each instruction is 20 bits. So the right answer for this question goes to 20 bits. Option B is the right answer. Yes. Very good, Soumit. Soumit Chaudhary, very good. 20 bits is the right answer. We have 1 hour session. So in this 1 hour, we will try to discuss about the 10 questions detailed. Okay. Chalo, let us go for the next question. Chalo, let us go for the next question. Second question. This is related to address bus. So topic related to or CPU or address bus. A digital computer has a address bus with 20 address lines. Then the range of the memory accessible is dash if the memory is byte addressable. So the question is asked on the range of the address. So everybody knows that if I'm having n address lines, any digital device, if it is having n address lines, it can support 2 power n memory locations. Am I right or not? 2 power n memory locations. That means how many address lines it is having now? It is having 20 address lines, my dear. So 20 address lines means what? 20 address lines means it supports from A0. So you can go like this. It is having 20 address lines now. So fatafat. So 20 address lines means A0, A1, A2, A3. Next, A4, A5, A6, A7. Next, A8, A9, A10, A11. Next, A12, A13, A14, A15. Next, A16, A17, A18. So these are the 20 address lines. With the 20 address lines, so what I can do now? With the 20 address lines, what I can do? So I can access a memory. So this is the memory diagram, dear students. So this is the memory chip. So this is the memory chip. So this memory chip starts from certain location. So this is the starting address and this is the ending address. So with these 20 address lines, so what is the range of the memory? So the minimum address location I can follow is, so the minimum address I can follow is what, my dear? So the minimum address is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. That means if you take 1 0 of hexadecimal, 4 zeros as 1 0 in hexadecimal format, this is 0, 0, 1, 2, 3, 4, 5 zeros. So 1, 2, 3, 4, 5 zeros. Hexa. Okay, na? 2, the maximum address location. So this is a minimum address location. So this is a minimum address location. And each address location can store how much data? Each address location can store byte type of the data. That's what he has given. That's what he has given in the question. If you see the question, a digital computer has an address bus with 20 address lines, then the range of the memory accessible is dash if the memory is byte addressable. So each memory location can store 8 bit of the data and the number of address lines is 20. With the 20 address lines, the minimum memory location that I can access is 000H and the maximum memory location I can access is what? That all ones, my dear. All must be so this all must be 1 means the range will be what? F, 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 that is 5 bits. So this will be F, triple F and double F. So the range will be what? So 5 zeros H to 5 Fs H hoga. And in terms of megabytes, if we talk, so the memory size is equal to how much? 2 power 20. 2 power 20 means 1 megabyte minus. So it can access a size of 1 megabyte and the range is 5 zeros to 5 FH. So in this, the right answer goes to option D is the best example I can tell you. 8086 microprocessor can address 20 address lines. So its range of memory is 1 megabyte memory. 8085 is having 16 address lines. So 16 address lines means 2 power 16. 2 power 16 means 2 power 6 into 2 power 10. That means 64 kilobytes. You understand? So this is a way you can remember. Okay. So let us go for the next question, my dear. Yes. Next question. Yes. This question, MCQ question, is related to addressing modes. What is the topic? Question is related to addressing modes, dear. So try to answer this question. Make it fast. Yes, Shaumit Chaudhary, try to answer this question. A very good, tricky question. Consider a PC relative addressing mode type control transfer instruction which jumps for an address of 1050 in memory. The effective address value of instruction is 250. The starting address of the instruction in memory if each instruction occupies 2 memory locations. First of all, you should understand what is this PC relative addressing. In PC relative addressing mode, what will be the representation, my dear? So it will be having a PC value plus effective address or offset. PC plus offset. So this PC plus offset is equal to the new address. Address, not new effective address, or we can call the effective address or the destination address. Am I right or not? In addition to PC value, we are also having the offset. Okay. So how to answer this question? Very good. 798, Dinesh. Okay, let us see. So first of all, what is given? There is a memory location. So let me take the memory location. So this is the memory location. It jumps to a memory location of how much? Consider a PC relative addressing mode type control transfer instruction which jumps for an address of 1050. So the destination address. So what is given in the question? The destination address. The destination is equal to PC plus relative address, that is effective address. The destination is given as 1050 and the effective address value is given in this question. If you see clearly, the effective address is given as 250, my dear. So this is given as 250. So from this we can get the PC value. So PC will be how much? 1050 minus 250. It will be coming as 800. It is coming as 800. So what is PC? PC represents the address of the next instruction to be executed. Okay. So that means if you take this as a memory, so this value is equal to 800. Okay. So this is the value represented by the PC. But remember, when PC is 800, the microprocessor is executing the present instruction. Yes or not? What is the PC meaning? PC always holds the address of next instruction. Am I right or not? Address of next instruction. That means what is the present instruction address? If you want to know, the present instruction address is not 800. Okay na? So present instruction is not 800. It will be what? The before address. But what is the size of each instruction? The size of each instruction is given as how much? two memory locations. That means if you take this as 799 and if you take this as a 798, so this is the present instruction, my dear. So this is the present instruction. The next instruction is availability 800. That is the meaning. Okay. So now this is the instruction. This is the instruction. So, but starting address of the instruction, this is a starting address of instruction. The right answer is 798 because question asked is the starting address of the instruction in memory if each instruction occupies. So what is answer? 797. Answer 798. Sorry, 790. Very good. Very good question. 798. All of you understood, my dear? 798 is the answer. Got it? Very good, Shaumit. Very good, Dinesh Teja. Have you followed my previous session? If you follow my previous sessions of one-shot series, we have the live classes of COA in YouTube. You please go through them, then definitely can understand these details. Chalo, let us go for the next question. Padafat. Yeah. This is question is related to MCQ. The topic is pipelining, my dear. So the topic is pipelining. So on pipelining, we are having one fundamental formula. What is pipelining? Pipelining means what? Prefetching the next instruction while the present instruction is under execution. Okay, please go through this question. Consider a 5-stage pipeline with delays of 4, 5, 3, 6, 5 and 8 nanoseconds. The pipeline timing for 100 inputs is dash nanosecond. What is the answer for this question, my dear? So, Dinesh, we are having certain formula. So, time of execution for pipelining is given by formula K plus N minus 1 into time of pipelining. Yes or not? So, if you see in this, what is the stage? K is what? K is the number of stages. K is the number of stages or segment. So, that is given as 5. N is what? N is the number of inputs. Number of inputs or tasks or the instructions, whatever. So, that is over 100. Next. What is the TP? Actually, TP should be single, but he has given each segment is collectively taking different values. So, what we have to take? We have to take the maximum of available time. So, that is a maximum of the list. So, this is 4, 5, 3, 6, 5, 8. So, what is the maximum? So, 8 nanoseconds is the maximum. So, now if you substitute, what is the answer, my dear? So, please use this formula. Most expected time of execution of pipelining will be given as K is the number of segments, that is given as number of stages 5 plus N is the number of tasks, that is 100 minus 1, and time of pipelining is given as 8 nanoseconds. So, how much is the answer? 99 plus 5, 104. 104 into 8, 32. I think 832 nanoseconds is the right answer. Am I right? 832 nanoseconds is the option C. Very expected question. Actually, this is derived for time of pipelining. One task will be K into TP and the remaining task will be N minus 1 into TP. So, this is the formula. Okay. You understand? So, the pipelining time will be K into TP and the remaining tasks are executed with N minus 1 TP. So, the total time will be K into TP plus N minus 1 into TP. If you take it, we will go. All of you following? Yes. Fatafat. Let us go for the next question. This is a MSQ. The MSQ question is related to computer organization. Topic is related to computer organization, about the blocks of organization. So, this computer organization. Which of the following statement is or true? This question is related to the DMA. I think all of you know about the DMA. DMA means direct memory access. Sometimes when the external peripheral wants to access the memory, always actually it has to wait for the permission of CPU. But we know that CPU is a very busy device. That's why we have certain interfacing facility. We have a mediator broker, so he will take care of this direct memory access. So what is this? DMA transfer is faster than the program data transfer. IO devices are faster than CPU. 8257 or 8237 is an example of DMA controller. The buses, this is not case, the buses. The buses are switched back to CPU when CPU disables the DMA hold signal, hold acknowledge signal. Yeah. So what is the answer here? IO devices are faster than CPU, Mr. Soumit Chaudhary. Please check your answer. Is IO device is faster? Is your keyboard and monitor is faster than the CPU? I am asking which of the following statement is true. Is your keyboard is faster than the CPU? Very good. Very good. DMA is the most fastest. Okay. So what is the DMA operation, my dear? So listen all of you. Fatafat. So this is our CPU. So this is the memory. This is certain device which wants to access the memory. So this is the memory. So this is some external device, X device, which is having some bunch of the data it wants to send to the memory. But to send the data to the memory, what actually basically we need? What is the basic thing we need? We need the buses. So the buses are under the control. This is the address bus and this is the data bus. Okay. Address bus, data bus, and this is the control bus. So these bus signals are under the control of the CPU. So if you want to transfer anything to the memory, we need the bus, but bus is under the control of the master CPU. So this X device has to wait when the processor becomes free, then only it can get it. So suppose if you're having bunch of devices, then it will be a time waste process for the external devices. That's why the CPU allotted one broker. So the broker name is DMA controller. So what is the broker name? So this broker is direct memory access controller. So whenever this particular X device is having certain data to send, first it will send a request signal to this particular DMA controller. Then this DMA controller will send a hold request signal, my dear. What signal? So we are going to give a hold request signal to the processor. If the processor is free, then it will send a acknowledge signal. Okay, now when I give the acknowledge signal, so this particular buses are switched. These particular buses are switched from the CPU to DMA controller. Then once the bus control comes, this DMA controller will give an acknowledge signal. Then the data will be transferred from the X device to the memory. But in between, if the CPU wants the bus, what it will do? It will make disable of this hold acknowledge signal. Then automatically this bus signal is again switched back to the CPU. CPU is a master. So what is the answers here? The DMA transfer is faster than the program data transfer. Yes. Every time you have to wait for the CPU. When the CPU is free, then only you have to give. So DMA is faster. So option A statement is sahi hai. IO devices like keyboard and monitor, they are never faster. Why? Because CPU runs with a frequency of 5 megahertz. When frequency is 5 megahertz, time is equal to 0.2 microseconds. So its T states are very fast. So IO devices are not faster. So DMA controller, the example for DMA controller is the 8257 or 8237. These are the DMA controller chip names. So this C is also correct. The buses are switched back to CPU when CPU disables the DMA hold acknowledge signal. So the right answers are A, C, D are the right answer. All of you understood, Soumit? Dinesh, is it clear? A, C, D are the right answer. Perfect. Sir, between programmed IO and interrupt driven IO, which is faster? Interrupt driven is faster. Okay, because whenever the interrupt is given, there is what a procedure called ISR procedure, interrupt service subroutine. So that interrupt service subroutine is also going to be executed the way we can answer. So let us go for the next question. Yeah, this is also question is on pipelining. Again, the topic is pipelining. The topic is pipelining. So try to answer this. Consider a pipelined processor with 5 stages and the clock speed of 5 GHz. The time of pipelining for 1000 instructions is dash nanosecond. Chalo. Very good, very good. What is the answer for this question? Consider a pipeline processor with 5 stages. So what is the time of execution in pipelining? That is k plus n minus 1 into tp. Okay, right? So number of stages, k is equal to how much? 5. And the clock number of instructions or tasks, that is equal to 1000. What is the time of pipelining? The time of pipelining is not given, right? The time of pipelining, cycle time for single pipelining is not given. But if we see, the clock speed is given, the frequency is given as 5 GHz, my dear. So frequency is given as 5 GHz means time kitna hoga? 1 by 5 into 10 to the power of 9 hoga. That means it becomes as 0.2 nanoseconds, my dear. So time of pipelining, this particular for one pipelining task, we can take it as 0.2 nanoseconds. So if we substitute, how much we are going to get now? Time of execution for the entire instructions of pipelining, k is the 5, k is 5, n is equal to 1000, sorry, n is equal to 1000 minus 1, and tp kitna hai? Tp is 0.2 nanoseconds. Please simplify and tell me what is the answer. This is 999 and 5. So I think how much you are going to get? What is the right answer? 5020 nanoseconds. Sure. The right answer is 5020. Different ways the questions can be expected in the pipelining. Chalo, let us go for the next question. Yeah, please answer this MSQ. Question is related to mission instructions again. Topic is related to mission instruction. Try to answer. Consider a system which supports 30 bits instruction. The system supports 45 one address instructions. Which of the following is or the possible size of the memory supported by the system? Try to answer. How your preparation going on? If you follow the digital electronics ECE people, I think all of you are very much confident in the digital electronics. A lot of content is given by our Chandan sir, and in our Gate Wallah channels, you are having a lot of content on digital electronics. But CO is an advanced subject. CO is given newly. Till now, we didn't have a bunch of questions in the Gate ECE paper. But the most expected topics I have chosen from the basic of CSE background. Okay. In computer science, what are the topics majorly they are stressing? Based on that, we have collected these. Consider a system which supports 30-bit instructions. The system supports 45 one address instructions. So very clearly given, it is having one address instruction. That means how to do? So that means that particular instruction is having address field. So it is having single address. So this is single address. So it is having address field. That's it. Next is the opcode. So what is the size? The size he has given as 30 bits. So what is the question? Consider a system which supports 30 bits instructions. The system supports 45 instructions, 45 unaddressed instructions. That means what is given? The number of instructions is given. Number of instructions is 45 means, my dear, what is the number of opcodes? number of operations or opcodes is equal to 45. That means to represent 45 opcodes, what should be the size of the opcode that should be mentioned here? So size of opcode, I told you, just like address lines. If you are having an address lines, you can support 2 power n memory locations. Similarly, if you are having an opcode of size of n bit, you can represent 2 power n operations. So 45 represent करने के लिए, what is the size of the opcode? If I take 5, 2 power 5, 32. Yes or not? That means you cannot support 45 operations. If you take 6, 2 power 6, 2 power 6 means 64. In 64, 45 opcodes can be accessible. So n will be 6. So you got the opcode size as 6 minus. So you got the opcode size as 6. When opcode size is 6, what is this address? Address field size 24. Am I right or not? That means the size of the address field, is how many bits? 20 bits. Sorry, 24 bits. All of you understanding, my dear? 24 bit. So this total together 30 bit instruction. So the memory accessible, so number of address lines is 24. Then the maximum memory accessible will be what? 2 power 24. 2 power 24 means 2 power 20. How I can write 2 power 4 into 2 power 20? I can write. Each memory location can store byte type of things. Yes or not? One memory location means 1 byte. So this is byte. So 2 power 4 means 16. 2 power 20 means MB. So 16 MB is the maximum memory. Maximum memory accessible is 16 megabytes. Am I right or not? So what is the right answer here? If you observe, which of the following are the possible size of the memory supported? See, the maximum is 16 KB. Sorry, maximum is 16 MB. That means the supportable memory is what? Supportable memory is less than or equal to 16 MB na? And it can access 1 MB, it can access 2 MB, it can access 3 MB, 4 MB, 5 MB, 10 MB, 12 MB, 14 MB, 16 MB. It cannot access 24 MB, it cannot access 32 MB. That means what is the right answer? It is a MSQ, my dear. It is a MSQ. So 1 KB it can access, 1 MB it can access, 16 MB it can access. The right answer is A, B, C. I think how many of you given? Dinesh, you have given C only. C is the wrong answer because it is MSQ, my dear Dinesh. Yeah. So A, B, C is the right answer. See the question. Is or, which of the following is or the possible size of the memory? Am I right or not? Thank you. You followed it. So please follow the technique. Don't be in a hurry. Whether it is a MCQ, NAT, MSQ, please take care of this, and based on that you try to understand. This question is again, topic is pipelining, because pipelining is one of the area where more questions can be expected. So this is question is pipelining speed up ratio. Pipelining speed up ratio. That means comparatively non-pipelining system, definitely a pipelining system will execute the things in a faster way. Comparatively non-pipeline system, a pipeline system speed will be improved. So he is asking what is the speed up ratio. See the question. A non-pipeline system takes 40 nanoseconds to process a task. The same task can be processed in 6 segment pipeline with a clock cycle of 10 nanoseconds. Determine the speed up ratio. Determine the speed up ratio of the pipeline for 100 tasks. So how to answer this question? Yeah, please try to think and execute it. So first of all, try to calculate the execution time of what? Non-pipeline. Okay, execution time of non-pipelining. Non-pipelining what? How much? Non-pipelining how much, my dear? See, one task 40 nanoseconds. So 40 nanoseconds for one task. Like that, how many tasks are there? 100 tasks are there. That means 4000 nanoseconds. Okay. So next, execution time of pipelining. Execution time of pipelining, we know the formula. What is the formula? K plus simple n minus 1 into TP. So what is the K? How many segments are there? K is the number of segments. The number of segments is 6 plus n is the number of task 100 minus 1. What is the time of pipelining? Time of pipelining is given as 10 nanoseconds. So how much we are going to get, my dear? Please calculate and tell me how much this is. This is 99. 99 plus 6, 105. 105 into 10. How much we are getting? 1000. How much you are getting? Please calculate and tell me. 99 plus 6, 105. 105 into 10. Okay, 1050 nano. So question asked is a speed up ratio. Speed up ratio means what? Which is faster. This pipelining is faster. So time of execution of pipelining, time of execution of non-pipelining. Okay, my dear. Or execution time of non-pipelining. You can write like this. If you're confused, you can write like this. This is execution time of non-pipelining. This is execution time of pipeline. So execution time of non-pipelining kitna hai? 4000 nanoseconds. This is 1050 nanoseconds. So how much? 400 by 105. 400 by 105 is more than 3. 400 by 105. How much you are going to get? It is coming around 3.8. 3.8 times faster. The right answer for this question here is 3.8 is the right answer. Option D is the option D. Very good, very good. Speed up ratio is one of the important area. So please focus on that particular formula. I am expecting a #1 question on the pipelining. For ECE people, they may not ask the depth of questions like CSE people, but sometimes there is a possibility to frame a question with a lengthy data to confuse you. You may compare with non-pipelining and pipelining. Okay, so don't confuse with all those things and try to understand the question clearly, and from the question, all of you are clear, my dear? Shall we go for the next question? Super 10 questions I am discussing. In the super 10 questions, I am collected some possible areas of the topics. Sumit Chaudhary actually speaking 2 marks also more than enough, because in the last year only we didn't get any question. I didn't find any questions in COA subject in the ECE paper till now. Till now I didn't find any questions in the 8 ECE paper. I collected the 2022 paper and 2021 paper. In 2022-2021 we didn't have any questions in the COA subject, but as it is included, we have to think of what type of questions can be expected. That I am going to. For CSE it is 10 marks, my dear. Why? Because for CSE branch, COA is a complete subject. Dinesh Teja, for CSE, COA is a complete subject. But here COA is a part of digital electronics. COA is not a complete subject here, Dinesh Teja. That is a fundamental difference. That's why when I am posting this particular slide also, I kept only for ECE. The reason is we are having digital electronics exclusive syllabus. In the digital electronics, we are having the COA as a part. Only 4 topics. That is one is instructions, machine instructions, addressing modes, CPU, pipelining. These are 4 topics we are having. Machine instructions, addressing modes, CPU, and pipeline. We don't have a full length subject, but we can. The 2 marks also matters, right? Sometimes for the rankers, the 2 marks, 1 mark also matters. And mostly from certain new areas, easy questions will come. Yeah, please go through this question. This question is related to topic is again pipelining. Please go through this question. Chalo. How to answer this question? Consider an instruction pipeline with 5 stages. 5 stages without any branch prediction. Fetch instruction, decode instruction, okay, fetch operand, execute instruction, write operand or write operand. So 5 stages hai. One is the fetch instruction, next decode instruction DI, next fetch operand, next execute instruction write back, execute instruction write operand or result. So this is one segment, second, third, fourth, fifth. Okay, so 5 segments, 5 stages. The stages delays for FI, DI, FO, EA and WR are 5, 7, 10. Just he has given the names to confuse or you kill your time. 5 nanoseconds, 7 nanoseconds, 7 nanoseconds, 10 nanoseconds, 8 nanoseconds, the last one 6 nanoseconds respectively. Understood? So what is the time of pipelining? The time of pipelining will be maximum of 5, 7, 10, 8, 6. That's it. You have to take the maximum time. Right? What is given here? There are some intermediate buffers. In this particular process, there may be certain wait states may be required for certain operations. I think all of you know it. Generally, when you're executing an instruction, we expect the task should be over by 3 T states. But suppose that external device is very slow, it may demand 1 more T state or 2 more T states extra. So that will be called as a buffer time. So here, there are intermediate storage buffers after each stage and the delay of each buffer is 1 nanosecond. That means there is a 1 nanosecond delay. A program consists of 12 instructions, so that's okay. And what is there is one extra. If you take the maximum for every operation, there is one extra. That means one delay of how much? 1 nanoseconds. Am I right or not? What to take? We have to take that one also into consideration now. Yes, 1 nanosecond delay is there. So this may 10 nanoseconds aega and this may 1 nanosecond aega. So pura milake how much? 11 nanoseconds we got it. So this is the time of pipelining. That's it. Just to confuse you, he will give this type of data. Don't worry about that, okay? Just to confuse you, he will give. Just you have to understand the concepts. 11 nanoseconds. So what is the execution time of pipelining? Everybody knows the formula. K plus n minus 1 into time of pipeline. What is the K, my dear? Here how many instructions are there? N is equal to 12 instructions. K is equal to 5. So question may what is given? K will be 5, N is equal to 12, TP is equal to 10 plus 1. So now you can substitute and tell me K is equal to 5, N is equal to 12 and TP is how much? 11 nanoseconds. So what is the answer, my dear? Please. 12 minus 1, 11, 11 plus 5, 16, 16 into 11, 16 into 11, 11 6 are 66, 11 1 are 11 plus 6, 17. So 176. How do you feel this question? The right answer for this question, what? The right answer for this question is 176. How do you feel this question? How do you feel this question? When you read this question, generally what happens in the time of examination, when you are preparing for the exam, when you are following this much lengthy depth questions, definitely will feel a bada question, very, very lengthy question, I will leave it. But actually, nothing is there. Just you have to study the question carefully, and there is a possibility of committing the mistake. People may forget this 1 nanosecond. Okay? People may forget this 1 nanosecond. Okay, so that is one important point. All of you enjoying, my dear? Chalo, I'm getting time. We are having one more back-to-back session, measurement session next time. Yeah, this is a simple MSQ. This is CISC and risk. CISC and risk. Actually, a topic nahi hai, but basics of computer organization. Which of the following statement is or true? Risk is costlier. I think all of you know about the risk. What is risk? Everybody knows, right? What is risk? Risk means reduced instruction set of computers. Instruction का complexity reduce हो गया. Please remember that. Complexity कम है in risk, not the less instructions. Less instructions are in CISC. CISC means complex instruction set of computer. Always remember, less number of instructions are available in CISC, but that single less instruction is very, very complex. It may be having many instructions internally. That is the meaning of that complexity. Risk is not like that. Risk is fragments. In CISC, one instruction, the same thing in risk, reduced complexity, it is going to be divided into group of instructions. Yeah. Now, what is the answer for this question? Which of the following statement is or true? Risk is costlier as compared to CISC. Risk means what? First of all, Shaumi Chaudhary, do you understand? Risk means, is it the number of instructions is less or the complexity of instruction is less? Please answer this question first, Shaumit. Risk means, is the number of instructions is less or the complexity of the instruction is less? Number of instructions less in risk is wrong statement here. Number of instructions are more in the risk. The risk contains fragmental instructions, whereas CISC contains single instruction which is more complexity. That's what I'm telling. CISC means complex instruction set of computer. Whatever the instructions are available in CISC, they are complex. Complex means what? One instruction itself can perform the 4 instructions task. Whereas risk means reduced instruction set of computers. That does not mean the instructions count is less. Instruction complexity is less. The risk contains simple instructions. Many simple instructions will be present. Many simple instructions is risk. One single complex instruction is CISC. CISC is having less number of instruction. Risk is having more number of instructions. Don't think in the risk the definition is reduced instruction set of computers. Based on that the number of instructions is less. That is wrong analysis. Risk means reduced complexity. Actually, whatever the instructions you have, the complexity is less, but the instructions are more. You understand, Divyesh Teja? They are having many simple instructions. Yeah, complexity is less. Means you have simplified. For example, mul is a complex instruction. The same multiplication you can do perform by repeated addition. Add. I want 5 into 3. I want 5 into 3 means directly I can write mul 5 comma 3. That is multiplication is a complex. Suppose the same 5 into 3 I can write 3 plus 3 plus 3 plus 3 plus or 5 plus 5 plus 5 plus. This is what? Risk. You have reduced the complexity, but the number of instructions are increased. That is the point. So risk is costlier? No, risk is cheap actually. Why? Because simple instructions. The simple instruction, it does not have complex instructions. Simple instructions, so they're easy to design. Okay, so simple to design. Simple instruction, simple to design. Simple to design. Simple to design is risk. Whereas CISC is complex to design. So CISC is costlier, not risk. So risk is cheaper, risk is inexpensive. Very good question. ऐसा theoretical questions आने के chances बहुत हैं. Very important है. Risk is inexpensive. Risks are faster as compared to CISC. Yes, definitely. Why? Because they are having very less simple instructions. Simple instructions can be fastly executed. B is correct. The software implemented for risk architecture is easier. Yes. Because complexity, for everything the trademark is complexity, my dear. For risk, complexity is less. For CISC, complexity is more. So when the complexity is less, cost will be less. Software cost will be less, but the number of instructions will be more. So this is also right. CISC required more RAM? No. CISC required more RAM compared to RISC. Sorry, here. Okay. CISC required more RAM as compared to RISC? No. Because CISC requires less code. Remember this point. CISC means less code, but complexity is there. Less code. So CISC required more RAM? No, this is wrong. You understand? Maza gaya? CISC requires less RAM comparatively RISC, because RISC is having more set of instructions. Complexity come hai. When complexity is less, you have to express that operation with multiple types of instructions. Understood? Understood all of you, Divyateja? For example, if there is no addressing modes, every time I have to get the number from the memory location. Suppose I am getting a number from every time a memory location. Move AL comma 0100. Next, move AL comma 0101. Move AL comma. Every time like this I am getting. Okay, but I can write like this: load accumulator with some address, SI address. Load accumulator with SI address. This SI I can write 0100, and I can go on pointing this SI automatically increment. Every time SI will be incremented. SI is another register. See, complexity is more here or here? Here more complexity, yeah? Here more complexity, yeah? Please tell me. It is having more complexity or it is having more complexity? Please tell me. Here SI is addressing to 0100, and we have to go to the 0100, and from the 0100 whatever the content is there, that we have to load into accumulator. Next again increment SI, auto increment. Okay, auto increment 0101, SI points to 0101, from 010 we have to get it. Okay, instead of single instruction of LDA-SI, the same operation if I want to complete, I can see the group of instructions. So this is the RISC category, this is CISC category. CISC contains less code, RISC contains more code, RISC contains more simple instructions, CISC contains less but complex instructions. Here, I think all of you enjoyed the session. So these are some super quality 10 questions, my dear. Because of the time framing, I have collected the 10 beautiful questions. I hope all of you enjoyed these 10 questions. With these 10 questions, you can think of what is the standard that you can expect from the ECE. I don't expect the CSE standard to the ECE student. Okay, computer science students, they are having that particular COA subject since the last 10 years. They are having the computer science people are having the COA subject in the GATE examination. But for ECE students, there is newly added under the digital electronics it added. So I don't suggest to follow the CSE lectures. Please follow our basic lectures and follow certain concepts from the microprocessor. I expect concept from the microprocessor to COA comparatively. Okay, na? So this is my session, my dear. So you can follow the session, and at the end of the session you can write your comments, valuable constructive suggestions, and if you like this session, try to share to your maximum friend circle. I wish you all the best for the upcoming GATE examination. Thank you one and all. Bye bye.